Hey guys, good night everybody. Um, just let me know if you guys can hear me, please, before we begin. All right, great. All right, so again, good night everybody. So I had a little time, so I just decided that I'm gonna give you all a free session this afternoon. I was gonna do the AdMats paper for you guys. All right. So maybe tomorrow I'll do the AdMats paper. I just skimmed the paper. The paper looked like it was easy-ish enough, I believe. I saw at least maybe two questions repeated in that paper. I don't know if you all realize that, but there were two repeats. Um, but let's focus on chemistry for tomorrow. All right. Now, I kind of skimmed through the chat here, and some of you all are wondering exactly what I'm going to do. So my actual crash course would have been on Saturday. I had a 6-hour class, all right, in preparation for tomorrow's exam. So today's class here, I'm just going to run through some exam papers with you guys, all right? Now, when it comes to chemistry, for those of you who don't know, I actually do mark chemistry for CXC. And what you all may not realize is that when it comes to the paper two questions actually repeat as well. All right, the syllabus has a fixed number of things that it can ask you in the exam. And what they've started doing, they started repeating some of the questions. So after a while, to me, the questions look like the same thing all the time. All right. Another piece of advice here, guys, if you know you have very limited time between now and tomorrow, my suggestion is to make sure that you prepare organic chemistry. There are two questions in that paper two that is going to be based on organic chemistry, and that's the third question and the fifth question on the paper. All right. Those questions are generally straightforward and they are quick to do in the exam. So you don't spend a lot of time working organic chemistry. It's just a matter of basically regurgitating what you've learned, right? That's basically what it is for those questions. Some people ask about green chemistry. So here's the thing. There are certain things that you're going to learn just before you go into the exam. Green chemistry is one of those things. All right. It is one of those things that I normally hope that doesn't come in the exam. And if it does come in the exam, they might ask you what is green chemistry. So make sure you know what is green chemistry. That's one. And there are 12 principles of green chemistry. Just make sure you learn at least 3 of them. Make sure you know them well. Okay. But you don't need to learn all 12 of them. Right? They're not going to ask you a question and tell you, hey, state all the principles of green chemistry. They're not going to do that. Okay. Make sure you know 3 of them well. All right. Okay, so I'm going to run through some exam questions. It's going to touch various topics for the exam. So let's look at this question here. A group of students was required to carry out an experiment to determine the melting point of an unknown solid A. The apparatus was set up as shown in figure 1. So first of all, guys, question 1 in your exam is going to be a data analysis. Just for your knowledge, one of the most common questions that they do bring for question 1 is rates of reactions. They also bring electrolysis. All right, those are common questions that they bring in question 1, or it could be a simple titration. That's typically what they bring in question 1. But in this question here, we are attempting to find the melting point of an unknown solid. So some of you all may have done this as a lab in school. So you have a Bunsen burner, the water bath here heated to 80 degrees, and the temperature readings were recorded every 10 minutes. Okay, so this is a typical cooling curve question here. Now we have some pictures here of some thermometer readings, and these readings are taken every minute for a period of 9 minutes here. So the first thing that we have to do, using the data, complete the table by inserting the thermometer readings from figure 1. So first of all, these kinds of questions are usually pretty nice because you basically reading off some pictures here. So I've seen exam questions where we have to read off temperature, or we may have to read off a time, all right, or even pH. Those are simple questions that we could do. So if we look at this table here, let's look at the pictures. So could you all tell me for 1 minute here, what temperature reading does that correspond to then? right? What temperature reading does that correspond to after 1 minute? Look at the graph. Look at the picture, sorry. Right? Now, I may not pay attention to every single thing being said in the chat, right? How long is it going to be? It could be about an hour and a half, maybe 2 hours, right? I have a little time right now, so. All right, everybody saying 73. Yeah, so if we look at this here, this corresponds to 71, 72, 73. So let's put this in our table here. This is 73. The next one here, so I'm just going to read them off quickly. So this one here is going to be 68 at 2 minutes. So this is 68. The next one is for 5 minutes, we're reading off, right? So this 5 minutes here corresponds to 65. So this here is going to be 65. Then we need to read off at 7 minutes. So that's this one here. That corresponds to 60. At 8 minutes, right, that corresponds to 55. So this is 55. And the last one, the 9 minutes, corresponds to 50. Okay, so this corresponds to 50. So we basically taken the data from the pictures and we placed it in a table, and we get an easy 4 marks here just for doing that. Now the next part, using the data in the table, we're going to plot a graph of temperature versus time on the grid provided. Now let me just give you a little pointer here. So generally for CSEC chemistry, we are not given marks for selecting scale and all of those things. When it comes to chemistry, they will normally label the axes for us. They will normally put the scale already. So it's just a matter of you plotting the points, right? Matter of you plotting the points. Some people asking what year is this? I think this is June 2016, right? I think it's June 2016. Okay. All right. So first of all, let me get this data across here. All right. So this is my data. And what we're going to do, we're going to plot this, right? We're going to plot this here. So first of all, we have 0, and that corresponds to 80. So 0 corresponds to 80. So they plotted those points already. So this is there. We have 1 against 73. So this here, now you all need to understand how to read your scale here. All right. Based on this graph here, every 2 units represents 1. Right. So that's 71, that's 72, that's 73, that's 74. So every 2 of those small lines represents 1 degree here. So if you want to plot 73, so this is going to be 71, 72. So this here corresponds to 73. The next one is 2 against 68. So this is 65, 66, 67. This is 68 here. Sorry, wait, hold on. Yeah, 2 against 68. The next one is 5 against 65. So 5 against 65 will be this guy here. All right. Then we have 7 against 60. So that's down here. Right, that's this one. Then we have 8 against 55. So that's going to be here. Right, 8 against 55. And then we have 9 against 50. So that's going to be here. All right. So it's a cooling curve. So we expect to get a curve. Okay. So in this case here, we're just going to draw. Right. So by the way, when you all are asked to plot a graph, usually we get a good bit of marks for plotting, but the plotting has to do with accuracy. Right. Make sure that you all draw with accuracy here. Okay. CXC is giving you marks for plotting the points accurately. So in this case here, right, you're not going to take your ruler. You're going to draw a nice smooth curve passing through the points. Right, so right, try your best to draw a smooth curve here, right? So this here represents my cooling curve for this particular data here, or this substance here that we don't know. Now the next part here now, they said list the 3 states of matter. Now this is a very easy question. This is like a Form 1 question here. Say the 3 states of matter. We have solids, we have liquids, right? And we have gases, right? So solid, liquid, gas. Now in a question like this here, guys, when you all see CXC is giving you 1 mark for this. In order for you to get that 1 mark, you have to get this correct, and this correct. If any one of them is missing, you are not getting that 1 mark. Okay, that's how they mark these things. For part 4, they want you to see what is meant by melting point. So when it comes to melting point, right? When it comes to melting point, basically we have a solid that is being converted into a liquid, or a liquid is being converted into a solid, right? So it's the constant temperature, right? It's the constant temperature, right, at which a solid, right, changes into a liquid, right? So what you all need to understand is, if you have a solid, right, and it's going into a liquid, energy is required to make this happen. This occurs at a constant temperature, right? So this phase change here for melting. So first of all, this is called melting. And melting takes place at a constant temperature, right? Constant temp, right? And by the way, if you all want to test to see if a substance is pure or not, one of the things that we do is actually find the melting point. So if you know the theoretical melting point of a substance is, let's say, 65 degrees, and you were to experimentally go and find the melting point, and you got the melting point not being 65, it means that the substance is not a pure substance. Okay? All right, now the next part here, part 5, based on the information from the graph plotted in A2, state the melting point of E. So let's go back to this graph here. Could you all tell me in the chat what's the melting point of this substance? What is the melting point of the substance here, guys? You can, yeah. Somebody asked about copper. Yeah, that's true, right? So if you have an alloy of copper and you have copper, so the melting point of copper will be a particular value. The alloy is going to have a melting point that is lower than the actual melting point. So you can, yeah, you can, right? Everybody's saying 65. Yep, it is 65 degrees. All you're really doing from a graph like this, and like I said, most of you all may have done this in school. You would have done this as an SBA lab. All we need to do is to read off this temperature here, right? And this temperature here corresponds to 65 degrees. So in this case here, your melting point is going to be 65 degrees. Okay? 65 degrees Celsius. Now, from the graph, identify the time range during which there should be a mixture of liquid and solid in the boiling tube. So they want a time range for which the... Okay, so first of all, let me just give you all a recap here about something. So when you have a substance that is cooling, so let's say this is temperature in degrees Celsius, and this is time here, what's going to happen is this. If we have a liquid and a liquid is cooling, the liquid temperature is going to drop, right? And then when it starts to solidify, it's going to do this. So in this particular graph here, there are several things we need to be aware of. So first of all, this temperature here corresponds to the melting point. And one of the things we need to know here is this. In this section of the graph here, right, that section there is liquid only. So that's a liquid only here in that section. In this flat section here, we have two phases existing at the same time. We have liquid, right, and we have solid existing here at the same time. And in this last section of the graph here, we only have a solid present. So you all need to understand, in a cooling curve, we have liquid only, we have solid and liquid, and that occurs when a phase change is taking place. And we have the last section, which is only a solid only. Now this question is asking us in which they want time range for which we have a liquid and a solid, right? Liquid and a solid. So could you all look at my graph here and tell me where do we have a liquid and a solid only? What's the time range here? Right? So I'm only paying attention to the ones who are here to learn, right? Random questions in the chat, I'm not really taking them on. So 3 to 5 minutes, that's what I'm seeing in the chat. So 3 to 5 minutes. So first of all, it's the straight line section, right? So here to here is the only straight line. So if I come down here, I need to read off this time here. That corresponds to 3 minutes. And we still have 65 here in this region. So we come down here. So we can say between 3 and 5 minutes, right? This interval here is where both phases exist at the same time. So I agree with that. That's 3 to 5 minutes. So that's true. So this here is 3 to 5 minutes. Okay. Next part. State one precaution other than wearing safety apparel, which could be taken during this experiment. So again, some of you all may have done this experiment in school. So you need to be able to give them some safety precautions done in a lab. So first of all, we're dealing with heat here. So therefore, you should use tongs, right, when handling this thing here, right? The other thing is that we have to be able to, you can use something called anti-bumping granules if you want. But basically, any safety precaution they will accept, right? Once you deal it with boiling tube and you deal with heating, so you try to keep the open end of the boiling tube away from you in case something comes out of the boiling tube. All right. So these are all safety precautions. Some people, they will use a glove in the lab. Some people use a lab coat. So any valid experimental precaution will work. All right. All right. What else? Yeah, wearing gloves. Yeah, you can use wearing gloves, point the test tube away from you. All of that could work, right? Yeah, once it's valid, there's only one mark, so they will accept anything. Okay. Now, complete figure 4 by drawing the arrangement of the particles of A at 0 minutes and 10 minutes, right? Use one dot to represent a particle. So first of all, when we go to 0 minutes, let's go to the graph here. Now 0 minutes here corresponds to this 80 degrees here. So we know that in that first section here, we have a liquid. So let's make sure at t is equal to 0, this here is going to correspond to a liquid. All right. And then B now, let's go back to, where is B now? That is, sorry, particles of A, 10 minutes. So let's go back here now. Where is 10 minutes? So 10 minutes is quite here. So we know at 10 minutes here, we only have a solid. So basically what they are really asking me for here is to draw a structure that will represent both a solid and a liquid. Okay. Now, first of all, let's deal with the solid. That's the easier one. Now, if I wanted to draw the particles in a solid, for those of you who don't know about the structure of a solid, the particles are arranged in a regular repeating pattern or a lattice structure. So in a solid, you have this ordered arrangement. So it's going to look something like this, right? They said use one dot to represent one particle. So this is how I would draw the solid. When it comes to the liquid though, what's going to happen here is that you may have clumps of particles together, right? So this, you might see some particles here, you might see some particles here, right? But there's no regular repeating pattern here, right? So you might see something like this. So the particles are not ordered like a solid. They're more spaced out, right? Remember, in a liquid, the particles are able to move freely within the body of the liquid. Okay, so they just want you to draw a diagram to represent a solid and a liquid. That's all they want. Okay. Next part here now. So part B. So qualitative analysis could also appear in question 1 of the exam. I think in the Jan 2026 paper, we had a qualitative question as well. In another experiment, a group of students was given an unknown solid B, and asked to identify it. They performed a series of tests, made some observations, and are recorded in the table below. Okay? Now, place a small portion of solid B in a test tube, and you heat it strongly in a Bunsen flame. A reddish brown gas evolved. They want the inference. Anybody know what the inference for this one is here? If you take a solid and you heat it and you get this reddish brown gas here, what is going to be this here? Oh, by the way, right? Remember I said at the beginning, there are some topics that you're going to learn just before you go in the exam. So in the morning, before you all go in the exam, I can't remember, is it morning or evening? Make sure, have your qualitative analysis close by. That's something you're going to learn just before you go in the exam. Green chemistry is also something I would suggest learning just before you go in the exam as well, right? Right, I'm looking at the answers here. So, first of all, one of the only colored gases that we need to know for the exam, right? So if you heat this thing here, first of all, you are strongly heating it, right? If you're strongly heating it and you get this reddish brown gas, right? What you're going to say here, my inference for this one here will be nitrogen dioxide present, NO2 present, right? NO2 is a brown gas and it's produced when you heat some nitrates, okay? So this is what I'm going to put here as my inference. Now the next part here, dissolve the remainder of B. So you have a sample of B here now. In distilled water, right? That's not. Dissolve the remainder of B in 10 cm cube of distilled water. Then filter, collect the filtrate, and divide the filtrate into 3 portions for you. Okay. So we took B and we dissolve it in water. And now we're going to do some tests here. So the first thing. To the first portion, we add in sodium hydroxide solution, slowly until in excess. So this is where your practical experience comes into play now. So sodium hydroxide is something that we use to identify cations. Now the first thing here, they said it's a white precipitate and it's soluble in excess. So first of all, you want the inference. Now, when I get a white precipitate with sodium hydroxide, it could be several things, right? So first of all, it could be Zn2+, it could be zinc, it could be lead, right? Pb2+, it could also be aluminium, right? And it could also be calcium, right? So when it comes to a white precipitate, it could be any one of them. So that's my inference. That's as much as I could see. Now the thing is, they told us that it is soluble in excess, right? It's soluble in excess. If it's soluble in excess, then it could be zinc, it could be lead, right? And it could be aluminium. We cannot identify at this stage what or which one they are, right? So it could be zinc, lead, or aluminium. Those zinc, lead, aluminium, right? Remember those form amphoteric oxides, right? Right? Somebody saying if they skip this part here, yeah. So if you all skip this part here, well, obviously no marks for you, right? You lose marks, that's it, right? This topic is called qualitative analysis, and it came in Jan 2026. So don't be surprised if it shows up in your exam tomorrow, okay? The next part here now, they said to a second portion. So now we're using aqueous ammonia. Now, aqueous ammonia is also used to identify cations, right? Aqueous ammonia is used to identify cations, right? So first of all, you get a white precipitate here with aqueous ammonia. Now, aqueous ammonia, guys, NH3 aqueous, right? That's actually ammonium hydroxide, right? NH4OH. Right? So aqueous ammonia is ammonium hydroxide. Now, you get a white precipitate here. If you get a white precipitate here, it could still be zinc, lead, or aluminium, right? Zinc, lead, or aluminium, right? Now, they said it is insoluble in excess. Now, if it is insoluble in excess, right, it could either be Pb2+, it could be lead, or it could be aluminium, right? If it was zinc, then zinc is soluble in excess. So again, this is something you have to learn just before you go to the exam, right? If you can't remember it. Now, the fifth part here, the third portion, we add aqueous potassium iodide. Now, potassium iodide is actually used for a confirmatory test for Pb2+, right? Potassium iodide is used for a confirmatory test to identify lead. And to know if lead is present, we get a bright yellow precipitate. And look, if you look at the observation here, you got a yellow precipitate. So that tells us something here. That tells us that Pb2+, right, is present. Right? Once you get a bright yellow precipitate with Ki, it means that Pb2+ is present. Now they want an ionic equation here. So all you need to do, you're going to put Pb2+. Now I tell my students here what, you all need to put your state symbols. So Pb2+ plus 2I minus, right? Because what's happening here is that the Ki is producing iodide ions. And then what's going to happen here is that you're going to get Pbi2, right? And this here is going to be a solid here, right? So that's what we see in the solution. That's your bright yellow precipitate here, okay? Now I know students look at this and they're thinking, what to do, all right? But this is what it is, right? This is what it is, right? No, the whole table is not worth 25 marks. The whole table is not worth 25 marks. The whole question is worth 25 marks. I think the table is worth, where I have it here, right? The table is only worth 3 and 2, 5 and 8 marks, right? The table is only worth 8 marks. Right, so that's question 1. Now, if you're all wondering what paper is this, those of you who came in late, this is June 2016. And if you're all wondering why am I doing June 2016, as I said in the beginning, they are repeating their paper 2 questions. The syllabus we are working on right now is actually effective May 2015. So if you have to revise for the exam, right, 2015 is where you need to start from, okay, in terms of exam prep. All right, next part here. So this is number 2 here, right? So I kind of glad these questions here. So first of all, we have to distinguish between an oxidizing agent and a reducing agent. So for those of you who don't know, when it comes to chemistry, we have reactions which are called redox reactions. Now, redox reactions are reactions that have both reduction taking place and oxidation taking place, okay? Now, for your exam, you all need to know what is meant by oxidation. So oxidation could be defined in 2 different ways. One, oxidation could be defined in terms of loss of electrons, right? Loss of electrons, that's oxidation. Or we can say that oxidation is an increase in oxidation number, right? Increase in oxidation number. Right? So that's oxidation. Now, reduction is the chemical opposite of what oxidation is. Now, some students, they kind of mix these things up, but the truth is, if you learn one of them, technically, you know what the other one is. So if they're the chemical opposite of each other, reduction has to be the gain of electrons, right? Oxidation has to be the gain of electrons. And when it comes to reduction, reduction is a decrease in oxidation number, right? Decrease in oxidation. Right? So you all need to know this, because CSEC can ask you to define oxidation and reduction in terms of electron loss or gain, or they can ask you in terms of oxidation numbers or oxidation state. Okay? All right, so the first part of the question says, distinguish between an oxidizing agent and a reducing agent. So whenever you have a substance, and this is something you have to know, when a substance behaves as an oxidizing agent, all right, it oxidizes something else and it is reduced in the process. So for an oxidizing agent, it is going to oxidize something, but at the same time, it is going to be reduced. When you have a reducing agent behaving as a reducing agent, it is going to reduce something else, and then it's going to be oxidized in the process. This is something that you have to make sure you have that clear in your minds, right? So an oxidizing agent will oxidize something else, and it's going to be reduced in the process. And the reducing agent is going to reduce something, and it's going to be oxidized in the process. Okay, so let's go back to the question itself. They said distinguish between oxidizing agent and reducing agent in terms of electron loss or gain. So first of all, let's look at this. So oxidizing agent, right? Now remember, an oxidizing agent is going to oxidize something, right? If it is going to oxidize something, it is going to be reduced in the process, right? It is going to be reduced in the process. Now, if it is reduced in the process, right, that is a reduction taking place here, right? Now, if it's a reduction, it's going to gain electrons, because we just said reduction is a gain of electrons. So it's a gain of electrons, right? So that's what's going to happen to your oxidizing agent. It is going to be reduced in the process, and it's going to gain electrons, because that process is going to cause it to be reduced. Now, when it comes to a reducing agent, so when a reducing agent acts as a reducing agent, it is oxidized. So the reducing agent is oxidized in the process. Now remember, oxidation is the loss of electrons. So the reducing agent is going to lose, right, electrons, right? So when they say distinguish between oxidizing agent, so all you're going to do is say oxidizing agent, right, is going to gain electrons, so gains electrons, right? Now, I always like to put a little extra inside it. It gains electrons, right? And you're going to say it is being, right, reduced, right? And for the reducing agent, right, it loses electrons, right? And you need to say it is being oxidized, right? So that's what I would say for an answer like this here, right? Right? What else do we have here in this question? Okay, so they gave them a table, right? They gave them a nice little table here. So Jaden carried out some tests and recorded the observations in table 3, right? Carried out the observations in table 3. So we have a test. So this first column here gives us some tests, and we have some observations taking place here. So an aqueous solution of C was added to potassium manganate 7, and they said the potassium manganate 7 changed from purple to pale pink. The second test says an aqueous solution of C was added to a solution of potassium iodide, and the potassium iodide changed from colorless to brown. And then we have some other stuff there. So we have different things taking place here. And they want us to state an oxidizing agent that is not mentioned. So first of all, you all need to be aware of certain oxidizing agents. So oxidizing agents you should know for the exam would be, right? So some oxidizing agents, we have acidified potassium manganate 7, which they mentioned in the table. This is an oxidizing agent. A second one here is acidified potassium dichromate 6, which is K2Cr2O7, right? So these are oxidizing agents, common oxidizing agents that appear in the exam. Acidified potassium manganate 7 is purple. It's a powerful oxidizing agent. When it behaves as an oxidizing agent, it is reduced, and the color changes from purple to colorless, or sometimes you might see purple to pale pink. Acidified potassium dichromate 6 though, what happens here is that it is an oxidizing agent, but when it does behave as an oxidizing agent, it is reduced in the process. What happens, there's a color change and it goes from orange to green. Okay, one of the things you need to understand here for this one here, why it changes from purple to colorless, it is a manganese that changes from +7 to +2. So the color change is really from oxidation state +7, which is purple, and it changes to colorless or pale pink, that's +2. In the case of the acidified potassium dichromate 6, the chromium changes from +6 oxidation state to +3. The +6 state is orange and the +3 state is green. Now they said state and oxidizing agent not mentioned here. So we're going to say acidified potassium dichromate 6. Right, that's what's happening here. Potassium dichromate 6. Right? Right? Everybody okay there? So here it is, right? So those of you who are in the live right now, I want you to do me a favor. I need you to hit like and I want you to click subscribe to my YouTube channel, right? I'm giving you all a bly here. So I want you all to give me a bly as well. So I want you to hit like and I want you to hit subscribe, all right? I'm trying to help as much of you guys as possible. For those of you who are in one of my first lives ever, so when it comes to chemistry, like I said, I do mark chemistry for CXC. In 2024, one of my students placed 4th in chemistry in CXC. In 2025, I had 2 students who placed on the merit list. That's 4th position and 9th position. Fingers crossed, right? I want to be able to get a student on the merit list in 2026 as well, right? For those of you students, those students who are in my class right now, my normal chemistry class, right? I'm looking forward to you guys making it to that list, all right? All right, good. So let's continue, right? Take notes of what I'm saying here when it comes to these things, right? So that's the first part, right? That's the first part. Now let's see what's happening here now. All right, so they said identify whether solution C is acting as an oxidizing agent or a reducing agent in test 1 and test 2. Now let's go to test 1 here. So this is test 1 here, and we are using acidified potassium manganate 7. Now acidified potassium manganate 7 is an oxidizing agent. Now if it's an oxidizing agent, it is going to oxidize something else and it's going to be reduced in the process. Now to know if it is being reduced, there's going to be a color change. So based on this here, we know that it changed from purple to pale pink. So therefore, it was reduced in the process. Now, if it was reduced in the process, it means that this substance C here was a reducing agent. So that's what you're going to tell them. You're going to say that in this here, so C is a reducing agent. It is reducing the potassium manganate 7, right? So that's what you're going to say for this part here. It's a reducing agent. When we come to test 2 now, let's look at test 2 and see what's happening here. So in test 2, right, in test 2, we are taking C and you're reacting it with potassium iodide. Now the potassium iodide changed from colorless to brown. Now, when it comes to potassium iodide, so let's look at this here. We have Ki, aqueous, as potassium iodide. Potassium iodide is colorless. But in potassium iodide, we have K plus and we have I minus. So we have the iodide ion present in potassium iodide. Now what's actually happening here, if we change from colorless to brown, it means that iodine is being produced. So basically this is what's happening. You have I minus, aqueous, and what's happening here is that that is changing to iodine, which is I2 aqueous. So this is colorless, right? And this here is brown. So this is what's happening here. This is brown. Now, in terms of oxidation numbers, this changes from -1 and iodine has an oxidation number of 0. So you're going from -1 to 0. That's an increase. If you go from -1 to 0, that's an increase. So that means that the I minus is being oxidized. So this whole process here is an oxidizing process, right? Or oxidation is taking place here, right? So if oxidation is taking place here, it means that that substance C here is actually behaving as an oxidizing agent. So the second test here, C is acting, right, as an oxidizing agent. Right? So that's my answer for that part here, right? That's my answer for that part. Let's see what else I have in this question. Right, so that's part 2. In this one here, with reference to oxidation states, okay, so we have to explain each of our answers. Now I kind of explained the second one already, right? But I want us to explain our answers. So in this case here, so test 1 was the KMNO4. So that's the H plus KMNO4. Right? So what's happening here is that the manganese, right, changes from, so this is how you're going to answer a question like this to get full marks, right? So the manganese changes from oxidation state right, +7, right? So +7 is the purple color, right, to +2, which is the pale pink that they're talking about, right? So you're changing from +7 to +2. This is an, so you're going to say this is a decrease, right? And when we have a decrease here, that is called reduction. So if that is reduction, it means that C is a reducing agent. Okay, so you have to be crystal clear in terms of what you're saying in order to get the marks, right? All right, so that is test 1. For the second test now, we're going to say now this is the Ki, right? Potassium iodide. So what happens here is that the iodine, right, changes from oxidation state right? You're going from -1, right, which is the colorless, right, to 0, right, which is the brown color, right? Now you're going to say this is an increase, right? And if it's an increase, that is oxidation, right? So therefore C is an oxidizing agent. Now if you notice how I'm structuring my answer here, it is a very clear way of structuring my answer. Okay? If you want to get full marks here, you have to be clear in your analysis. All right? So that is test 1, test 2. What else we have here? All right, write an ionic equation with state symbols for the reaction that took place in test 3. Now let's go back to test 3 here. A strip of iron was placed into an aqueous copper-2 sulfate solution. The blue solution faded and a brown deposit settled. So here's what's happening here. So we have a scenario like this. We have a beaker here. And the beaker has a piece of iron, right, that is inside it, right? And this solution here is a blue solution. So this solution here is aqueous copper-2 sulfate. Now they love to bring copper-2 sulfate in displacement reactions. So this is blue, right? This is blue here. And this here is iron. So when you see a question like this here, this has to do with something called a displacement reaction. Now, for the exam, guys, you all need to know your reactivity series. However you want to remember it, that's fine. So this is what the reactivity series looks like. Right. Normally I put H on the side here and we'll put copper here. Now what you need to remember for the reactivity series is that the metals are arranged in order of reactivity. All right. Potassium is the most reactive and reactivity decreases as we go down the reactivity series. Now in this question here, you are attempting to do a displacement reaction. So we're trying to compare iron. So you're taking a solid piece of iron and you're adding that to a copper to sulfate solution. Now, because iron is above copper in the reactivity series here, we expect a displacement reaction to take place. So in the displacement reaction, I want you to understand what's happening here. So the iron, because it's more reactive, it is going to go into solution as Fe2+. Now, because copper is less reactive, your Cu2+, and by the way, the reason why this is blue has to do with the presence of Cu2+ aqueous ions. So the Cu2+ is actually going to be converted into copper solid. So what you end up get that is forming around the iron here, right, is actually copper solid being formed. Okay, so it's going to be a displacement reaction. Now CSEC wants us to write an ionic equation. Now when I have to write an ionic equation, what I normally do, I do this. So you have Fe solid. So what I will do, I will write the equation as it's supposed to be first of all. So Fe solid plus copper to sulfate aqueous, right? This is going to produce, so it's a displacement reaction. Iron is above, so it's going to displace it. So if it displaces it, you're going to get FeSO4 aqueous. So you're going to get iron 2 sulfate, plus you're going to get copper solid being produced. So CuSA. Now this equation as it stands is already balanced. That's why CSEC only giving it 2 marks here, right? Now first of all, what I'm going to do, I need to write an ionic equation. So let's write this over first of all. So we have Fe, we have S, copper 2 sulfate is ionic. So that's Cu2+, SO4 2 minus, aqueous. Then on this side here now, this is also ionic. So this is Fe2+, right, SO4 2 minus, aqueous, right, plus copper solid, right, plus copper solid. Now what you need to do next now is to identify any I'm missing something. This is SO4 2 minus. So you're going to identify any spectator ions in this chemical reaction. Now spectator ions are ions that don't take part in the chemical reaction. If you look on the left hand side here, you have sulfate. And if you look on the right hand side, you have sulfate as well. Nothing is happening to the sulfate, so it's a spectator ion. So if you want to write an ionic equation, you need to remove this from both sides of the equation. So CSEC wants, and watch what they wanted, they want the ionic equation. That's what they want. So in this case here, you're going to write Fe solid, right, plus Cu2+, right, aqueous, they want the state symbols, produces Fe2+, right, aqueous, plus we're going to get Cu solid. I know some of you are watching this and thinking, first time I seen this, right? But make sure, right, make sure you know how to write an ionic equation here, right? Right. So that is part 4. Now the next part, with reference to the electrochemical series, explain the difference in observation between test 3 and test 4. So let's back up a sec here. What is test 3? What is test 4? So this test here is what we just worked out here, right? In this particular one here, a strip of silver is placed into, so what's happening here is this. So you have a scenario where we have silver. So this is Ag solid, that's silver. And you're going to mix that now with a solution of copper to sulfate, that's CuSO4 aqueous. And we're going to figure out what's going to happen here. So first of all, in the reactivity series, silver is actually below copper, right? So in the reactivity series, silver is below copper, right? Now they said explain the difference in observations between test 3 and 4. Now, in a question like this here, I can see students losing marks because they are not answering exactly what is being asked, right? So to answer this question here, right? So test 3, that's the one with the iron and the copper 2 sulfate. So in the third test, what you're going to tell them is that Fe is above, right, copper in the react. Now they call it the electrochemical series. So let's use the same words they want here. In the electrochemical series, right? Therefore, displaces. Look at the words I'm using here, right? Sorry. Right. So Fe is above copper in electrochemical series, therefore displaces, right, the Cu2 plus from aqueous solution, right? Right. So we answered what's happening in the third test, right? In test 4 now, right? You're going to see that silver, so Ag is below copper in the electrochemical series. Right, so it's below copper in the electrochemical series and therefore cannot displace, right, Cu2 plus from aqueous solution. Right, so that's a proper answer here, right? So remember, like I said, guys, I see what students write in the exam, and a lot of the times they tend to old talk, or sometimes they know the work, but they're not answering the questions properly, right? Not answering the questions properly. Okay. Right? As you go down the reactivity series, they become less reactive, right? They become less reactive. All right, so that's number 2, right? The third question, right? The third question is organic, right? For me, this is usually the easiest questions on the paper, right? And this is how I train my chemistry class as well. Make sure they can answer organic questions. So they're going to get full marks in these questions, right? So the first part here, they want you to define structural isomerism, right? Define structural isomerism. So basically, organic compounds, right, having the same molecular formula, right, but different structural formula. Right? So this here is what structural isomerism is. This usually comes a lot in the exam, so make sure you learn this definition for structural isomerism. Now we have a compound P here. It's a hydrocarbon, and we want to state the name of this thing here. So first of all, they've given us a structure in one straight line here. So just for you, I'm going to draw the structure here. So we have a double bond in this compound here, right? So while I'm drawing this here, could you all tell me what homologous series does this compound belong to here, right? I'm just going to draw the structure. If you all know what homologous series this belongs to, let me know. 1, 2, 3. 1, 2, 3, 4, 5. right? I'm just drawing it out here so we can visualize what structure we have here. All right? Anybody know what homologous series this belongs to? All right, excellent. All right, everybody's saying alkene. For those of you who don't know, it is an alkene, and it has to do with the fact that this here is a double bond, right? So it is an alkene, right? It is an alkene. Now, let me see if you all can get this part correct here now. They said state the name of this alkene here. What you all going to say is the name of this. Right? Everybody who's confident about being an alkene, right? Let me hear what the name of this thing here. Aha. Okay, so some people are saying pentene, some people saying 1-pentene, some people saying pent-1-ene. All right. Now I'm seeing some of my students here from my class in the live chat here. So hopefully they know how to answer this. So let me just tell you something here, right? First of all, it has 5 carbons. So therefore we expect to see pent in the name. Okay. Now a lot of you all are saying pentene. But let me just tell you something here one time, right? If you've never seen this before, if you put pentene in the exam, you are getting that wrong. All right. If you all put pentene, you're going to get that wrong, right? I'm not just telling you this because I'm just saying this, right? I actually marked this particular question, third question in the exam. And if you put pentene, you are not going to get it correct. Just letting you know, all right? If the teachers in school have not told you that, that is the truth, right? You're not going to get this correct if you put pentene. So first of all, this is an alkene. Now, when it comes to an alkene, we have to specify the exact location of the double bond. So if I have to name this here, I'll have to number 1, 2, 3, 4, 5. It has 5 carbons, so I know pent is in the name. Okay? Now, your number left to right, and you number right to left as well. 1, 2, 3, 4, 5. Now, here's the thing. We must indicate the position of the double bond. So here's your options. The double bond is either located on the first carbon, the second carbon, the fifth carbon, or the fourth carbon. Now, when it comes to naming a compound, we will use the smallest number. So the smallest number is going to be a 1 there. So the name of this compound is actually, right, the name of this compound is actually 1-pentene, right, which is the easiest way to name it. Or it's called pent-1-ene. These are the only 2 correct answers, either this or this. If you put pentene alone, you are not going to get a mark, right? I just letting you know, right? So in this case here, we're going to say either 1-pentene, right? Or we can say pent-1-ene, right? So those are my answers here. Now the next part, they want you to state one physical property of this thing here, right? State one physical property here. Anybody know what physical property we can say here? Right? Somebody asking about it live. Yeah, it's going to be recorded, right? It's going to be recorded. So just just copy the link or something here, right? But it'll be there. It'll be there. Let me see what people saying here. I'm curious to see what people say here, right? So first of all, they want and I don't want you all to Google the answer, right? So first of all, they want a physical property. In chemistry, when they ask us for physical property, they're talking about things like if it's a solid, liquid, or gas. They're talking about melting point. They're talking about boiling point. They're talking about viscosity, right? Density. That's what they mean by physical property here. Okay. So first of all, when it comes to the alkenes, so ethene, right, which is the first member. Then we have propene, right? Methyl probute. We have 1-butene, right? We have one pentene. So for your knowledge, right, you see ethene, propene, and one butene. These are gases. And this one here, we start to go to a liquid. So first of all, they want one physical property. Well, this is definitely going to be a liquid, right? So it's going to be a liquid. You can say things like low melting point, right, and boiling point, right? They just want one, but I'm just giving you one or two here, right? So don't go in the exam and tell them it's a gas, right? You're not going to get a mark if you put gas. Now, the third part here, they said state one chemical property. Now, CXC sometimes complain that students don't know the difference between chemical property and physical property, right? Right? Yeah, people talking about low density. Yeah, that's true. I want to hear what chemical property you're going to tell them, right? Give me a chemical property. Oh, yeah. So, okay. So somebody said yellow flame, right? Yeah, that's a physical thing that's happening there, right? All right. So some people saying unsaturated. So when they ask about chemical properties, let me give you a little suggestion here. You can give them a chemical reaction, right? You can give them a chemical reaction here. So it's an alkene, right? It's an alkene. When it comes to chemical reactions here, if I take an alkene and I react it with aqueous bromine, the aqueous bromine will go from reddish brown to colorless. That's one answer you can give. Another answer that you can give is that an alkene will react with acidified potassium manganate 7 and it'll go from purple to colorless. Those are two chemical tests. If I were you, that's what I would put as my answer. So you can say it, right, decolorizes, right, aqueous bromine. Right, so this is just one possible answer here, right? Decolorizes aqueous bromine, and we can say it goes from reddish brown to colorless. Right, so that's what's happening here. They want a chemical, once they ask you for a chemical property, write down some kind of chemical reaction that's taking place here. Okay, now the next part here, they want us to draw right? So they want us to draw a fully displayed, right? So let's go back here. Let me see what they asked and how much marks it is. Do they want us to name it? No, they don't want us to name it, right? All right. So they said draw fully displayed structural formula of compound P. So first of all, we said that compound P, now I drew one of the structures already here. So you want isomers, right? You want isomers. So remember, isomers have the same molecular formula, but different structural formula. So the first thing I drew here would have been this, right? 1, 2, 3, 4, 5. Okay. Now, just for your knowledge, whenever CXC asks us to draw an organic molecule, you are given 2 marks, right? You're given 2 marks. So that's why you see they're giving you 4 in total here. So in this case here, it's going to be this. Okay. All right. So this one here is our 1-pentene. Now, if you want to draw an isomer for this compound here, guys, all you need to do is to shift the position of the double bond to create a second isomer. So instead of having the double bond between the first and the second carbon, I'm going to shift it. And I'm going to put it here now. 1, 2, 3, 4, 5. So in this case here, when you're all drawing, make sure you only have 4 bonds around each carbon. So you have to be careful. Students make mistakes with their alkenes. So this here is going to be, right? So this first one here, the formula is actually C5H10. The formula for the second one is still C5H10, right? So they are isomers, but they have different structures. So this compound here is actually going to be 2-pentene. right? So that's the isomer, 2-pentene, okay? Right, let's see what else we have here. Somebody's asking if you'll be able to draw a polyamide. Yeah, those are things that can come in the exam, right? Those are things that can come in the exam. Like I said, you all literally have little time between today and tomorrow. If you have to study anything, make sure you study organic. It's gonna come, right? 30 marks out of the 100 in the paper too is organic, all right? All right, so let's see what else we have here now. So we have our next one here, compound P. So we have a different compound here now. Oh, sorry, no, this is the same compound P. It reacts with hydrogen gas in the presence of catalyst to form Q. Now, first of all, you're taking an alkene, right? And you're reacting that with H2 gas, and you're producing, right? So they said draw the fully displaced structure of one branched isomer of compound Q. So first of all, if I take an alkene and I react it with hydrogen, what I'm going to get is an alkene. Okay? So this particular reaction here with hydrogen, you need a nickel catalyst. So a nickel catalyst is what's happening here, and the temperature is about 150 degrees Celsius. You'll have to know this, right? This particular chemical reaction is called hydrogenation. It is how you take fats and oils and you convert them into margarine. All right? So in this case here, they want you to draw the fully displaced structure of one branch isomer. So first of all, if I take any one of these alkenes here and I react it with hydrogen, what's going to happen is that I'm going to get pentane, right? 1, 2, 3, 4, 5. So first of all, read the question carefully, because this is a kind of trick question here though. So first of all, once you react it with hydrogen, you're going to get pentane, right? That's what you're going to get first of all. But if you read the question carefully, the question is asking you something in particular. It says, right? It says they want the fully displaced structure of one branch isomer, right? So this is very specific here. So first of all, this compound here is called pentane. And what we want to do, we want to write down or draw, right? You want to draw an isomer of pentane, right? And it has to be branched. That's what it, right? It wants it to be branched. So first of all, that'll be easy to do. All I need to do, I can do 1, 2, 3, 4, and let's create a branch right here. All right, so I still have my 5 carbons here, but I'm creating a branch alkene. Okay. Right, so this here is a branch one. So this is going to be your answer. You're not going to put this as your answer because this is a straight chain. They specify that they want a branch chain here. Okay. Now, they said state one physical property of compound Q. So first of all, compound Q is an alkene now, right? It's an alkene. When it comes to the first members of the alkene homologous series, we have CH4, that's methane, right? I'm gonna put the words instead, right? So we have methane, right? We have ethane, we have propane, right? Methane probute, we have butane, and then we have pentane, right? We have pentane. Now, again, these first 4 here, these are gases, right? And then this one here is a liquid. So when they ask me for a physical property here, I just gonna hit them liquid one time, right? So you could say liquid, you could say low BP, right? Low melting point, right? So that's it. That's all you need to say here for this part. What else do we have here again? All right, this is the last part of this question here, right? So the following diagram shows the structure of compound R. So first of all, when you get a structure, try to identify the functional group that is present. In this case here, you will notice that you have the OH group. This OH group here is referred to as the hydroxyl group, right? And we find the hydroxyl group in an alcohol. So they said state the name. So it's an alcohol. Anybody know the name of this alcohol? Right? What's the name of this alcohol here? No. Some, some, right? Somebody say white oak. Yeah, so some people ask somebody, yeah, I don't set the exam, you know, guys, right? I don't set the exam, right? But I do mark the exam, right? I do mark for a CSEC. Right, so some people getting a little smarter now. People saying 2-pentanol, right? 2-pentanol, right? So let's check that. Let's make sure we know. Right, so first of all, I like to draw my diagrams, right? I like to visually see what I'm looking at, right? So if I were to draw the alcohol, and you could do the same thing in the exam too if you want. So this here is what this alcohol is going to look like. We have CH, and the OH is up here. And then we have CH3. Right? I feel like I'm missing. Yeah, I'm missing a CH2, right? Hold on. All right, so first of all, let's see if we can name this. Now, this is an alcohol. When it comes to an alcohol, you need to specify the position of your OH group. Okay, so naming it is very important. So we go 1, 2, 3, 4, 5. Then you're going to number right to left. 1, 2, 3, 4, 5. Now you have to look at the diagram here now, and you're going to identify where is that OH attached. So the OH is attached to this carbon here, and the options are 4 and 2. But remember, we're using a smaller number, all right? So in this case here, we can see that the name of this thing here is 2. 1, 2, 3, 4, 5. It has 5 carbons, so it's 2-pentanol, right? So that's the name of the alcohol, or you can call it pent-2-all, right? So those are the two possible names here. So we can say 2-pentanol, right? Or pent, right? That's how it, sorry. All right, so that's the proper name there. All right, now state the conditions required, right, for dehydration of ethanol. Now, first of all, you want to dehydrate ethanol. Now, this is something you guys have to be careful with, right? So, anybody know the conditions for dehydrating ethanol? All right. So I seen good some good answers here. So first of all, let me just tell you all something one time. Sometimes we see students will just write this, right? Now, if you all put this alone, you don't get a mark. You must specify concentrated, all right? It's concentrated sulfuric acid, and the temperature, right, is about 170 degrees Celsius, right? 170 degrees Celsius. right? Oh yeah, somebody said I spelled the word wrong. Yeah, it's pent, right? Sorry about that. Right? So make sure when you all have questions involving concentrated, if you don't put the concentrated before the sulfuric acid, you lose the mark there. Okay? So that's your third question there in that paper. Right, this next one here, it's a question that they like to bring, so all right, so in this question here, it's about diamond and graphite. So graphite and diamond are two allotropes of carbon, and the first thing they want you to define the term allotrope. So allotropes, right? Those are different physical forms, right, of the same element, right? Different physical forms of the same element in the same physical state. Right? And then they want us to draw. I think that's what they want. Illustrate your answer. Right. So you want to draw diamond and graphite. So guys, this is something you have to know how to draw. So first of all, when it comes to diamond, we have each carbon is bonded to 4 other carbons, right? So this is what you're going to do here. Make sure. So this is something I remember practicing since I was in Form 4, right? So this is what the structure of diamond, right, looks like. So you have this tetrahedral arrangement, right? So make sure you draw something like this, right? Right, so I'm just doing a partial structure here, right? You can extend it if you want, no need to, but that's partial structure of diamond. When it comes to graphite, you have these hexagonal layers, right? So make sure you draw these layers here, right? Right, try to draw them neatly, of course, in the exam, right? Not kind of crap off with like what I'm drawing here, right? Right, so this is one layer here. You're going to draw a second layer if you want. Well, not if you want, you have to, right? So right, so again, make sure you can draw these two structures, right? And normally we put these dashed lines here to represent our weak forces or van der Waals forces. Oh, by the way, 6 marks to this, huh? There's a lot of marks. This next part here, what they want. Right, like metals, graphite can conduct electricity, but diamond cannot conduct electricity. So you guys have to be able to compare the properties of diamond and graphite in relation to the structure and bonding present. So first of all, graphite conducts electricity. Describe the bonding present in metals. So first of all, you all need to be able to describe metallic bonding. So you just need to say positive metal ions, right? Or what we call cations. So positive metal ions are held together by a C of negative electrons. That's all you need to say here in order to get the marks. All right, so that's metallic bonding in a nutshell. Explain in terms of bonding why graphite conducts electricity but diamond does not. So first of all, you're gonna say each carbon in graphite is bonded to 3 carbon atoms. Right? This leaves 1 electron available right per carbon. Right? These electrons are delocalized. Right? So this is why graphite conducts, right? In diamond, all you need to say here, now first of all, they didn't give us enough lines to write out the answer properly. So in diamond, right, there are no free electrons. So you could just say that there are no free electrons, right, for conduction. Right, that's basically what's happening. All right, now what else they want me to do here? All right, this next part here, they said sodium chloride and calcium oxide both have similar giant ionic crystalline structures with high melting points. However, the melting point of calcium oxide is higher than sodium chloride. Sketch the lattice structure for sodium chloride and suggest why its melting point is lower than calcium oxide. So first of all, for a question like this here, you have to be able to draw sodium chloride. So for me, I'm just going to give you what the structure looks like. Okay. So sodium chloride, you have to be able to draw this in the exam, and it has a cubic structure like this. Every sodium ion is surrounded by 6 chloride ions. All right. And also every chloride ion is surrounded by 6 sodium ions. So it's a cubic structure. So your syllabus says you have to be able to draw sodium chloride. This is what it looks like. And they said now suggest why the melting point for sodium chloride is lower. So first of all, we have sodium chloride, right? In sodium chloride, you have Na plus and you have Cl minus. When it comes to calcium oxide, that's CaO, we have Ca2 plus and we have O2 minus. So what you're going to notice, right? What you're going to notice between the sodium ion and the chloride ion, you have singly charged ions present. But if you look at the calcium oxide, you have Ca2 plus and O2 minus. So therefore, the charges in the calcium oxide are stronger. So therefore, the ionic bonding in calcium oxide is going to be stronger than sodium chloride. So we expect the melting point for calcium oxide to be much larger. Okay, that's what's happening here. So you're looking at the charges present. You have Na plus Cl minus. Those are single charges. So you have a certain force there. But if you look at the calcium oxide, you have Ca2 plus O2 minus. Those are doubly charged ions. So therefore, the force of attraction there is stronger. That's why the melting point is going to be high. Right? Right? There's so many things in the chat here, right? So many things in the chat. I can't read all, right? I'll just make a skim through here. Right? I've seen people saying all official answers need to be in pen. Now, ideally, right, you all should write all your answers in pen. However, if you have to draw a diagram, you're going to draw in pencil, please. Okay? In case you make a mistake, right? In case you make a mistake, even if you do the entire exam in pencil, it will be corrected. Eh? Just letting you know. Right? Let's see what else we have here now. Right, so this is number 5. Right, this is number 5. So in your exam tomorrow, question 5 is also going to be on organic as well. So first of all, right, methane is the simplest hydrocarbon known to man. Okay, identify the type of bonding present in methane and state a reason for your answer. So first of all, this is what methane looks like, right? So this is what methane looks like. So first of all, they want you to identify the type of bonding present. So first of all, the bonding, right, present, right, is going to be covalent bonding, right? It is covalent bonding here, right? Now look at the marks here. This is where some students, they don't pay attention to the amount of marks being given. So you're going to get 1 mark definitely for saying this, but you have 2 marks here to state what's going to happen or why does this happen. Now, a covalent bond, right? So you're going to say carbon is a non-metal, right? And hydrogen is a non-metal as well. Right? So we have both carbon and hydrogen being non-metals, right? So these atoms, right, form a covalent bond, right, by sharing their valence electrons. Right? This is what you need to see here if you want to get full marks of this here, right? So always look at the marks. The marks is usually a guide in terms of what you need to see, right? Usually a guide in terms of what you need to see. Okay. What else we have here? So methane, like other alkanes, is generally unreactive. However, under certain conditions, it can undergo reaction with chlorine to form carbon tetrachloride or CCl4. They want you to write a balance equation for this. So first of all, we have CH4, and you want to react this thing here with Cl2, right? Now, what is going to happen here is that each of these hydrogen here, they're going to be replaced with chlorine atoms, right? To give me that CCl4 that we have here. So this here is going to be CCl4, right? So that's your carbon tetrachloride. But we're going to have another product coming out here, right? Whenever you replace the H's, what you're going to get HCl being produced. So this here is going to be HCl. Now, first of all, we need to balance this thing here, all right? So we have 4. So this here is going to be, let's see. I'll put a 4 here, and I'll put a 4 here. Will it balance? We have 1 carbon left, 1 carbon right. We have 4 hydrogen, 4 hydrogen. We have 4 to 8 chlorine. We have 4. Okay, so this is it, right? So this is the balance. They ask you for a balance equation. That's what we're going to put in. Okay. Right. What else do we have here? Right, state the type of reaction taking place and identify the reaction conditions. So first of all, if you're replacing the H's with Cl, it's a substitution reaction. So the type of reaction is substitution. Right, so you get a mark for saying substitution, and we want the reaction conditions. So first of all, when chlorine reacts with an alkene, the conditions will be ultraviolet light. Right, so you need UV light or ultraviolet light. Right, so that's your 2 marks there. What else they want? This one here is a nice question. So identify and draw the structural formula of the alkene and the acid from the list of molecular formula. Now, what they've done here, they've given us the molecular formula of 4 different compounds. We have C4H8, we have C4H10, we have C4H8O2, and we have C4H10O. Now, they want you to identify which one is the alkene. So first of all, an alkene has a general formula given by CnH2n. So you have to look at which one here will give me that. So obviously the alkene in this case here will be C4H8. Okay, and they want us to draw it. So let's go with 1, 2, right? Now it's an alkene, so we expect to see a double bond. Right, so this here is the C4H8. Now, the next one here now, we're trying to figure out which one is the acid. All right, you all know what the acid is? If I call this A, B, C, and D. Anybody know what the acid is? All right, which one is the acid? Okay, so some of y'all kind of smart here, right? So yeah, I agree this is the acid, because first of all, when it comes to an acid has this here as its functional group. So what you're going to notice, it should have 2 oxygen present. So the fact that you have 2 oxygen here tells me that that's the acid. So this acid here has 4 carbons. 1, 2. So you're going to draw this. Right? So this here is going to be the acid. You have 4 carbons, that's your acid. And wait, that's not, hold on. Identify and draw. Okay, well, this one here is the acid, which is C4H8O2. Okay, I thought they wanted us to name it. Right, that's what I was checking for. Right, what else we have here now? Right, for each of the following pairs of compounds, identify a test that can be used to distinguish between them. So first of all, we have an alkane and an alkene. You need to be able to use that test to differentiate. So first of all, we can use aqueous bromine, right? So you can say add aqueous bromine to both. Right, to both of them. This is how you're going to describe this test. Now we need to say what happens to the alkane, or we could start with the alkene, it don't matter. So for the alkene, right, we're going to get rapid decolorization. So you get rapid decolorization, indicate the color change. So it goes from reddish brown to colorless, right? That's the color change we're going to get. For the alkene now, so you need to specify if the alkene is reacted, what happens, right? So we get no change, right? And when we say no change, what that means is that the solution, right, stays reddish brown. Right? So it's because the alkane has the double bond, that's why we get a chemical reaction. Now the next part here now, we want to do a test to differentiate between the alkene and the carboxylic acid. That's a good one. Anybody know, or anybody, what do you think we should do there? Right? For each of the following, identify a test that could identify or to distinguish between both of them. If you all saw this in the exam tomorrow, what will you say? I'm curious to see what people say in here. Some people say use a magnesium strip, add alcohol, blue litmus. Oh, I see. Okay, so I'm seeing some good answers, right? I'm seeing some good answers here. Okay. So first of all, right, let me agree with some of you all. So some of you are saying use litmus. I agree. If I use litmus here, I could identify the carboxylic acid, right? The alkene will not give me that reaction. So yeah, I agree. So there are multiple answers here. So you can use litmus, right? Only the acid is going to react, right? You can also add, so check this. You can add sodium carbonate, Na2CO3. And what is going to happen is that you're going to get CO2 gas being produced, right? So you're going to get CO2 gas being produced. You're not going to get a reaction with the litmus, sorry, with the alkene. So the litmus here, it'll go from blue, right, to red, right? Let me see what else some people said here. I've seen some nice answers in the chat here. Add a metal. Yes, you can add a metal, you know. Add a metal and somebody's asking a good question here. If you go over the line. So let me tell you something here. Sometimes even when I'm marking, if somebody has an answer in the corner, we still mark it, right? So if you are outside of the line, you still get marks for that, right? So don't stress, right? Yeah, if you go over the line, that's not a big deal, okay? Even some spelling words, there are some words that expect you to spell correctly, right? But generally, if the spelling is off, that's okay. You're not going to lose marks for that, unless it's a specific word they want us to spell. Right? Adding a base. But if you add the base, what is he? You have to tell them, if you add the base, then what? What happens when you add the base? Right? Somebody put dissolving in water. What you should do is to give a chemical test, right? Give a chemical test. Somebody said esterification. Yes, but I was looking more for a direct test. For esterification, you're going to have to add an alcohol, right? So you're going to have to try to create an ester. To me, that's too much work. All right. So just go with the litmus if you want, or you can go with the sodium carbonate. All right. All right. What else we have here? Is that it for that question? Okay, good. All right. Next one here. All right. So this is the last question on this paper here. Caribbean islands are known for their many resources. For example, the ore of aluminium is found in Jamaica and Guyana. Describe the extraction of aluminium from its named ore and include in your description one ionic equation, right? One ionic equation. So first of all, aluminium is extracted from its ore, right? So all right, so let's first of all, let's state what the ore is when it comes to aluminium. So the ore is Al2O3, right? That's aluminium oxide. Right, now, first of all, the purified ore, right, is, so the ore, so let's put, so the purified ore is added to something called molten cryolite. So CSEC can ask you, why do we use molten cryolite? So the reason for adding the molten cryolite is to reduce the melting point of the aluminium oxide. So therefore, the electrolysis can take place at a lower temperature, right? So the purified ore is added to the molten cryolite, and then the mixture, right, is electrolyzed. Right, so we use an electrolysis here in order to separate the ore. So first of all, we have Al2O3. So that means that you're going to have Al3 plus, and you're also going to have O2 minus. So those are the two ions that are present. So sometimes they may ask you to draw the diagram, but I'm not going to draw the diagram here. But in this case here, we can have Al3 plus, right? So let's, hold on. So let's write what happened at the anode and what's happening at the cathode. So the anode is your positive terminal. So if it's a positive terminal, we expect the oxide ions to be discharged. So we have O2 minus, right? is going to produce, this is 2, and you're going to get O2 gas, right, plus 4 electrons, right? So that's what's happening with the oxide at the cathode. And the cathode is your negative electrode. So the Al3 plus is going to go here. So that's Al3 plus, right? It's going to gain 3 electrons, and it's going to give us aluminium, right? It's molten aluminium, so it's aluminium liquid, right? So these are the reactions taking place at the anode and the cathode. There are other things that they can ask us in this particular question, right? One of them is, why does the anode have to be continuously replaced? So what's happening at the anode is that oxygen gas is being produced. And since we're using graphite electrodes, graphite is carbon. Carbon plus the oxygen gas being produced, right? We get carbon dioxide. So an exam question could be, why does the anode have to be replaced continuously? It has to do with the fact that the oxygen gas being produced at the anode reacts with the carbon and you get CO2. So therefore the anode has to be replenished over time. What else I want here, right? So this is a 5-mark question here. So we just need to say electrolysis, right? Make sure you say graphite electrodes, right? Always use this here as your guide in terms of what you're going to say. Okay. What else they want now? Right? Although aluminium is mined in the Caribbean, the extraction of aluminium usually takes place in other countries. Suggest why it may be difficult to extract aluminium in the Caribbean. So first of all, right, the electrolysis, right, requires, right, a large amount, right, of cheap, right, large amount of cheap electricity, right? Because remember, it's electrolysis, right? Right, so electrolysis requires a large amount of cheap electricity, which is unavailable, right? So we could say which is unavailable in most Caribbean countries. Right, so that's for that one there. What else we have here? Right. An alloy can be described as a mixed metal solution. Aluminium forms an alloy with magnesium, right? So this here, what they're referring to is something called duralumin, right? So the syllabus says you need to know an alloy, a named alloy of aluminium. This is one of them, right? This is one of them, right? In this case here, identify this alloy, or they want you to identify, right? So the alloy is duralumin. All right, duralumin is made up of aluminium as well as magnesium, right? So identify this. No, wait, hold on. I'll put duralumin here, but sorry, this one. Aluminium and magnesium. All right, let me do a quick double check if you. Because we have magnesium and we have duralumin, right? Okay. So let me just tell you something here one time, right? Just in case they show up in the exam tomorrow, let's not mix it up. So first of all, there are two common alloys that we can name here, especially when it comes to aluminium, right? So first of all, we have duralumin, right, which is the most common one. If they were to ask me to name this in the exam, I will do that, right? So duralumin is 94%, right, aluminium, right, and it's about 4% copper, right? That's typically what, now it has magnesium and it has manganese, right? It does have these inside it, right? But that's duralumin. But we also have a next one called magnesium, right? So this question is a little wicked, right? Because yes, duralumin has magnesium in it, right? But they said it forms an alloy with magnesium, right? Using aircrafts. But let's check this here. So for magnesium, we have 95% aluminium, right? And we have about 5% magnesium, right? So if you notice something here, the first alloy, it does have some magnesium in it, but the second one here has a larger percentage, right? That's like about 5%. So in this case here, and by the way, both of these alloys are used to make aircraft. Both of them are used, okay? So in this case here, the alloy is going to be magnesium, right? So this is a kind of trick question here though, okay? So they want the alloy, and they said to suggest why is it better to use it rather than a pure metal in the manufacture of an aircraft. So first of all, we're using it so the alloy is used instead of the pure metal right, the pure aluminum, right, because, right, it is stronger, right? So normally we use an alloy in place of a pure metal because you have enhanced the properties here. So it's stronger, right? And it's stronger and lighter, right? So this is one reason, right? Because it's stronger and lighter, right? So this is one reason here. Now, since it's 5 marks here, we need to put a little more, right? So we could say it is more resistant to corrosion, right, than pure aluminum. Okay, so again, like I said, it's kind of tricky here, right? But I'll go with magnesium in this case here, right? Not duralumin. Let's see what else we have here. So some metals. So some metals may be useful to man, yet harmful to the environment. Comment on the statement here by using mercury, right? Using mercury. So first of all, right, when it comes to things like this, we have to be careful, right? One sec here. Okay. So they want us to show, right? So the element that they want us to look at here is mercury. And they said that some are useful, right? And some are harmful, right? So we want to comment on the statement in relation to mercury. So first of all, let's look at usefulness, right? So you have to be balanced in your answer. So usefulness, right? Why do we use, or how do we use mercury, right? So use in the manufacture, right, of thermometers, right? So that's a good use, right? So we use it in thermometers, right? And harmful, right? So when it comes to harmfulness here, right, mercury actually damages right? The central nervous system. So if you ingest mercury, right, what is going to happen is that you're going to damage your nervous system and you're going to basically have muscular coordination problems, right? So it's damages the central nervous system. Right? So your syllabus says make sure we know some usefulness of your metals. Certain metals here, like for example, iron. Now this question was specific for mercury, but iron is found in hemoglobin. Right? Magnesium is found in chlorophyll. Right? So just be aware of some of these things here. Okay? Right? I know some of you all probably want me to go on for like 5 hours and thing, right? But that can't happen today. All right, so I just looking through some of the things here, right? Because I said I was only going for 2 hours. So all right, some people saying chem clashing with building tech tomorrow. So normally the schools will have to deal with that. They will have to keep you guys there a little longer. All right. So let me just tell you the structure of your exam paper. It's going to be 6 questions. We know what question 3 is going to be based on, and question 5. It is going to be based on organic chem. All right. I honestly suspect that we will probably get alcohols and carboxylic acids. I feel, right? They may train polymers or even soap. The last question in the paper is inorganic generally. And when it comes on inorganic, it's either non-metals or metals. Now, they haven't brought metals in a while, so maybe we might get some metals tomorrow. Maybe. Green chemistry. So those of you asking about green chemistry, make sure you know the definition for green chemistry and make sure you learn off at least 3 of them properly. There are 12 principles, but you need to learn off at least 3 of them. Make sure you know it well, those 3. Okay? Yeah, just read the book and memorize. Yeah, that's as much as I can't give you anything more than that, right? You have to read it. Yeah, somebody said mercury is used to extract gold. Yep, that's true. That's a good one. Right? That's a good one. Let me just tell you something here, right? Let me just show you something. Sometimes CXC will ask you to write a balanced chemical equation for some reaction. So let's say we have magnesium and you want to react that with, let's say, hydrochloric acid. HCl produces, you're going to get a salt. In this case here, the salt is MgCl2. And because it's a metal plus an acid, you're going to get H2 gas. Okay? Now, when they ask you for a balanced chemical equation, CXC will give you 3 marks for that. If you only write this alone, you will get 1 mark. Now, in order to get this 1 mark here, you must have this correct, you must have this correct, or this correct. If any one of them is wrong, you don't get a mark. Right? That's for balancing a chemical equation. The second mark goes for your state symbols. So when I put Mg solid, right, plus HCl aqueous, right, you're going to get MgCl2 aqueous plus H2 gas. All right. So for this here, if you write this in the exam, you will get 2 marks, right? And that is because you have the correct state symbols. Now, every single state symbol has to be correct for you to get a second mark. And the final mark now, right, if you want to get the full 3 marks, you must have Mg solid, right, plus 2 HCl aqueous produces MgCl2, right, aqueous plus H2 gas, right? And if you have this here, then you're going to get your full 3 marks, right? This is going to be your 3 marks. Okay. Now, for a chemical reaction like this, CSEC can ask you to write the ionic equation for this reaction. It's a common reaction. If you have to do that, then you can see, right? First of all, Mg solid plus 2. Now, hydrochloric acid is ionic, so it's going to be H plus Cl minus, aqueous, produces, this is also ionic, so this is Mg2 plus Cl minus, well, hold on, let's put a 2 here, right? So this is 2 Cl minus, right, aqueous, plus H2 gas, right? Now, again, like we did previously, we look to see which ions are spectator ions. If you look at this carefully, this Cl minus on the left, and you have Cl minus on the right here, it remains the same. So this Cl minus is a spectator ion. So if CSEC were to ask us to write the ionic equation, it is going to be Mg solid plus 2H plus aqueous produces Mg2 plus aqueous plus H2 gas, right? This here is an ionic equation for this reaction, right? This is a very common thing that comes in the exam. So this is an ionic equation, okay? Some people are asking about a calculation. Sure, I can do one calculation because they tend to bring some of these things sometimes. So let's say we would take, let's say, 0.5 grams, right? Magnesium is added to, let's say, 20 cm cube, right, of, actually, wait, hold on. Let's go with 100 cm cube of 0.1 mole per dm cube, right, 8 cm, right? And I want to calculate the volume of hydrogen gas produced at RTP, right? This is a typical exam question here, right? And CSEC can break it up into parts for you guys here. So first of all, let's work out how many moles of magnesium do I have, right? Let's work out that. So first of all, right, magnesium, right, has a mass number of 24, okay? So we can say that 24 grams magnesium is really 1 mole, right? Now I know some of you all, when you learn in moles, you learn of formulas. I don't teach my class any formulas, right? I don't teach my class formulas. Once you have proper statements, then we can work things out. So if you want to work out 4.5 grams, everything is about cross multiplying. So you're going to take this number, multiply by this, divided by this. So this is going to be 0.5 multiplied by 1 over 24. So I can work out how many moles of magnesium we have there. So that's 0.5 divided by 24. So we're going to get 0.021, right? Or better yet, let's, right? So what I've done there, I've worked out how many moles of magnesium I'm actually mixing in this thing here, right? Now let's work out how many moles of hydrochloric acid we have there now. So to do that, we're going to use the concentration data to figure that out. So in this case here, we have the concentration is 0.1 mole per dm cube. What does that tell you? That tells you that in 1000 cm cube, right, HCl, we actually have 0.1 moles. Okay, so next thing, you're using 100 cm cube. So let's figure out how many moles we have there. So 100 cm cube, HCl, right? Again, you're cross multiplying. So it's 100 multiplied by 0.1 all over 1000, right? So that's going to be, oh, by the way, any paper 2, work with your calculator, right? You are allowed your calculator here. So this is going to be 0.01, right? Okay, so now, based on the equation that we have there, right? We had an equation just now that says magnesium plus 2HCl produces MgCl2 plus H2 gas, right? That's a chemical reaction taking place here. Now, the amount of moles that we have here, right? You have 0.0208 moles of magnesium, and you have 0.01 moles of hydrochloric acid. So you need to figure out, whenever you have a scenario like this here, we need to figure out what is my limiting reagent, right? What's my limiting reagent? Now, what you can do, the mole ratio here between the magnesium and the HCl is a 1:2 ratio. So if you have 0.0208 moles of magnesium, that tells us that you should react that with 2 by 0.08, 0.208, sorry, right? Which is 0.0416. Now what I'm using here, I'm using the mole ratio. 1 mole of magnesium reacts with 2 moles HCl. So if I have 0.028 magnesium, it should react with 0.0416. But then you're going to realize, wait a minute, but this is not what I have. So therefore, you have excess magnesium in this chemical reaction. So what you're going to do, you're going to have to use the acid in order to predict how much H2 is going to be produced. So if we use the same mole ratio here, right? If I have 0.01 here, it means that the amount of magnesium that is going to react with 0.01 is going to be 0.01 divided by 2. So this is going to be 0.005. I know some of you all watching this and thinking, oh my God, what are you doing? Right? What are you doing here? Right? So yes, whenever you have a chemical reaction taking place here, you need to first figure out which is your limiting reagent. The limiting reagent is the one that is in the smaller quantity in terms of moles. All right? All right, let me see what people are saying here. All right, so some of you all might be getting a little lost right now, right? But what's going to happen here, this here is your limiting reagent. So if you have this amount of acid, the amount of acid to this here, right, is 2:1. So in this case here, if you want to figure out how many moles of H2 is going to be produced, it is going to be 0.005, right? Based on the mole ratio, this is how much hydrogen gas is going to be produced. Now, since we're asking about RTP here, so 1 mole, right, of H2 at RTP, right, is 24 dm cube. So these numbers are given to you in the exam. Gases could be given in terms of RTP or STP. You don't need to remember the numbers, they typically give us it. But if I know I'm producing 0.005 moles, so this is 0.005 moles, right, H2 at RTP, then the amount of H2 that is going to be produced will be 0.005 multiplied by 24, right, and you're going to get 0.12 dm cube, right? All right. All right, guys. So, so some of you all, right, would have practiced a lot. You would have revised a lot. All right. So, some of you all are a little panic right now, right? Like I said, if you want to gain some marks, right, please make sure and review organic chemistry, right? Now, like I said, I only had time for about 2 hours, right? I only had time for about 2 hours. So I just want to wish everybody good luck in the chemistry exam tomorrow. We'll see how it comes, right? Do not give up as yet. You still have some time between now and tomorrow, right? Predictions, right? I feel like we're gonna get metals tomorrow. That's my feeling, right? I could be wrong, but I feel we're gonna get metals, right? All right, guys, so I'm gonna pause here for now. So enjoy the rest of your afternoon. Good luck to you guys. I hope that you all learned something at least. All right, so take care, everybody. Have a good night. All right, good luck with the rest of your studies. All right, later, people.